So today's gonna be super similar to yesterday, just in the fact that we're gonna be doing more with linear inequalities. Just today is going to be a system of linear inequalities. So therefore, the system of linear inequalities is gonna be two or more. When you get into Algebra 2, you might get into a little bit of linear programming, which involves 3 or 4 inequalities at one time. Here for this class, this is just the introduction to it. So we're just gonna see 2. Likely, and we'll just stick it at 2 and we can do that. So that's what we're going to do. So the other part of this is like yesterday when we graphed the linear inequality, we had to graph a boundary line, whether it was solid or dashed, and then we had to shade one direction or the other. Now we're going to be shading 2 different directions as far as we have 2 different lines, and we want to find that shading overlap. So the region that's shaded by all the linear inequalities, that's what I'll be considering my solution. However, before we get to that, though, we need to test our ability to figure out if it is a solution. So how would we tell is -1, 5, is that going to be a solution to this system of equations? So real fast, before I get going again, let's talk about a system. I'll just draw a system of equations. So we did this yesterday. Okay, here, I've amended a little bit today, and here it is. Here is the shaded region. This is going to be the solution. So any point in this region, it made this equation true as far as the orange line. It made this equation true as far as the green line. So therefore, this equation, this is the area that makes both of them true, okay? I don't have a picture to look at. So how do I tell, is -1, 5 a solution to this system of equations? How do we tell that? Any takers? So we know that x is -1, we know y is 5. So let's go into that first one. We're going to drop that into my first inequality. 5 is less than 5. Is 5 less than 5? It is not. So we've already struck out. We don't need the second one. However, we'll just practice on the second one. 5 is greater than -1 minus 4. Five is greater than -5. That one actually checks out, but because of this guy right here, this is not a solution. Okay. I think we can still keep number 9 in the picture, but we're going to move on to number 10. Number 10, again, we're going to see is 1, 4 a solution to this system of equations. So we're going to have 4 is greater than 3 times 1 plus 1. That looks horrible, so we'll try it again. 3 times 1 plus 1 is 4 is greater than or equal to 4. Is that a true statement? Sorry, I put the bar underneath there. Is 4 is equal to 4. So that one actually checks out. We're good there. The other one is going to be 4 is greater than 1 minus 1. What is 1 minus 1? That is 0. That one checks out too. So because they are both true, yes is a solution. So if I go too fast, I'll have these notes posted in the module when we finish up today. Okay, so the graph of a linear system is going to be the graph. We're going to graph all the solutions in the system. Okay, and we have a 2-step process. So really, what this is an extension of yesterday. We're just going to graph inequalities, linear inequalities, exactly like we did yesterday. The only difference is now we're going to have 2 inequalities at a time, and we're going to have to find a common shaded region. Okay, that's the only difference between yesterday and today. So pop it into yesterday. So we're going to keep with the red line. Okay, number 1 is we have equation number 1 here is already in slope intercept form for us. So hopefully we can just look at that and be able to go, because that matches up with what we did yesterday. So where do we start that line at? We're going to start that at 5. 1, 2, 3, 4, 5. So we started at 5, and from 5, I'm going to go down 2 and over 1, down 2 and over 1, down 2 and over 1. We just keep on doing that all the way down. I'm going to make as many points as I possibly can, just because it's really hard to make straight lines on this. So I could go up 2, but then I got to go left 1. Up 2 and left 1. So there, I've just given dots all the way across there where my line goes. Okay. A very apropos strategy. If you're not going to get us, if we had a straight edge and we were using a straight edge, we could plot 2 points and go with it. However, that's not necessarily the case. Okay. Now, do you remember from yesterday? We're going to draw a dashed line or a solid line here. It's a dashed line because there is no equal to sign underneath my inequality, so therefore it's going to be a dashed line. So we go through here, dash, 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 dash. I'm certain you saying dash 15 times made that very best. Very good. Okay. Now, referring back to yesterday, we're going to shade there. Okay. Where are we going to shade? Again, we have 2 areas we can shade. We can shade the y-axis below the line that I just drew, or I can shade the y-axis above the line that I just drew. Which one am I doing? This one has a greater than sign, so we want to shade the y-axis above the line, which means that we are shading this area over here. Okay, that's what we did yesterday. That's no additional information. Okay, no additional steps from yesterday. Here's the additional part. Now we're going to put 2 graphs on two equations, 2 graphs on one graph. No, 2 lines on one graph. There we go. If I could talk right. We're going to start at -3. With -3, we're going to go up 1 and over 1. So up 1 and over 1. I get bored with that, so I go up 2 and over 2. We could go up 3 and over 3. It doesn't really matter. I just need to get myself this line drawn. When I pop that line down, what am I going to draw a solid one or a dashed one? Man, you guys are good. Solid line, there it is. Okay, there's my solid line. And now the question is, are we going to shade above the solid line or below the solid line? Okay, again, we're going to shade the y-axis below the line that I just drew. So here's the y-axis above the line, here's the y-axis below the line, and I'm going to then shade the area below the line. Now here's the additional step is I need to identify the region that is the solution to both linear inequalities. So what region is both? Well, that would be the overlapping region. That would be this region, that would be right in here, this pink region. So our graphs can get really, really sloppy, okay? And this first one, it's okay to be sloppy, but I'm gonna come back and show you a different way that I do it. It's up to you whether you do it or not. It's just, okay, I'm gonna erase all my shading. Okay, so I just have the 2 lines. Okay, now what happens when 2 lines intersect? It creates 1, 2, 3, 4 distinct regions, right? Will we agree for that? 2 lines intersect, 4 regions are created. One of those regions is the right answer, okay? If I go back to that first line, I want to shade above this red line. So of 1, 2, 3, or 4, which ones are above the red line? 2 and 3 are both above the red line, okay? On the blue line, I wanted to shade above the blue line. So of 2 or 3, which one is below the blue line? 3 is, and sure enough, that is the region that we had shaded as my winning region, okay? So if you don't want to make your graph all messy, you don't have to. We can shade at the very, very end. If you want to shade as you go, I'm not going to care, okay? All right, number 4, it's nice. It's already set up for us, ready to go. So I would just say, graph it there at your table and you can check yourself, but it's up to you. So I'm gonna go ahead and graph these and we'll see where we're at. Down 2 and over 3, down 2 and over 3, down 2 and over 2. Yeah. Yeah. Are they restarting it? Are they restarting it? I see 0, 0. Okay. Again, just to keep us moving here, I don't know, hopefully most of us got a graph. I see still a few pins moving, but hopefully we got this graph. But again, if you can just graph the two lines. When we graph the two lines, and it doesn't matter where you number them, but I'm going to number them 1, 2, 3, and 4, and I have to figure out which region is going to be the common region between both. So it's just a narrowing process. So this, if we go back and look here, I made, this one was my red line here. This equation was my blue line here. So I want to shade where for the red line? I want to shade below the red line. So that means I'm either looking at 3 or I'm looking at 4. Those are the two, that has to be the regions, have to be the 4 for the blue line to work. For the red line to work, excuse me. Okay, what about the blue line? Where am I going to shade on the blue line? And again, because this is greater than, I'm going to shade above the blue line. So this is the region above the blue line. I already narrowed it down between 3 and 4. So that means that 4 is going to be the region that I want to shade. So again, if you want to color in 2 different directions and just figure it out that way, I am fine with that. If you want to number your regions and do this, okay? But we just need to figure out some type of system, okay? All right. Only 2 more to go, and then we'll call it a day for notes. So number one, that first graph is already good for us. So again, I will just let you graph those as you can, and I will just do them up here. Okay, so line number 2 leaves us at a crossroads. We have to understand in line number 2, are you going to do intercepts? Are you going to solve for y? I'm going to solve for y just because it's my intercepts are really, really close. On the next one, I'll graph by intercepts. Or, you know, if you want to graph all of these by slope, I mean, you have that option, okay? However, we have to remember that on this one, we had to divide by a -1. So I have to remember I need to switch that inequality sign. So we end up with 2x minus 3. Any Meatloaf fans out here? Me, I actually, Meatloaf is in the singer versus Meatloaf is in the food. Who's Meatloaf? Okay, I get it. He died today. Meatloaf died today. He's a singer. What? Yeah, I could do anything for love, but I can't do that. That guy. Okay. Previously in a section far away, when we saw this represents what type of solution?
No.
This is no solution because I have parallel lines. If I look, my lines have the same exact slope here. All right, I get a 2x is up here. I've got a 2x down here. So they have the same slope there. I'm not going to touch. However, this being a linear inequality, this possibly could have a solution if there's an overlapping area. Now, the odd part about this is there's only 1, 2, or 3 areas. So here there's only 3 distinct areas that we can put the solution as. If we look at the red line, I was supposed to shade where to the red line? I needed to shade as less than, so I should shade below the red line. So that means I'm shading this area. So that means I can rule out number 1 there. Okay, on the blue line, you shading below, above or below the blue line? Now, if you look at my original was a less than. However, in the process here, I had to divide by a negative. I had to switch this to greater than. So we're actually going to shade above the blue line. So we're going to shade up here. So that means that area 2 is going to be my winner. Now, I can still have no solution here because if it had asked me to shade above the red line and below the blue line, then I would have had no solution because they would have never overlapped. Okay. One more to go, and then we will call it a day. Now we have to remember, we've only got one variable here. Y is greater than or equal to -1. What does that mean? We have to remember this is going to be a horizontal line. It's going to be a solid one. I forgot to look. Did I draw my other? Oh, nobody stopped me. Number 5. We got something wrong on number 5. What do we got wrong on number 5? Yeah, it's supposed to be a dash line. So no, done with that. We can fix this. Here we go. All right. Now I am actually going to do this in the other way. Again, we can put it in slope intercept form. Do that if that's your preference. That is completely up to you. But I'm going to say that 5x is equal to -18. And when I divide by 5, I'm going to have a decimal. That x-intercept is going to be -3.6. I'm going to say that 3y is equal to -18. And when I divide that out, I'm going to get a -6. So these are pretty far apart. 1, 2, 3, 4, 5, and 6 on the y-axis. 1, 2, 3, almost 4 on the x-axis. And now I'm going to draw a solid or dashed line. So there's my dashed line. And we have 1, 2, 3, or 4 areas. So we're back to those 4 areas. So if I go to y is greater, which of those areas is greater than -1? Greater than -1. We want to shade above -1. So that means we're going to shade up here. So that means that 1 and 2 are my 2. These are the 2 possible answers. So that means I have eliminated 4. I've eliminated 4 and 3. All right. So of 1 or 2, which one of these lies? And I'll go back to my sign. Now, here I suggest you test points, but because this is positive, we're okay. We're going to shade above that line. So which one is above, 1 or 2? 2 is above the line. So that means we're going to come in here and we're going to shade that. The only thing that we have to remember is if this sign is ever negative, like it was over here, That means I have to switch the inequality sign or switch your direction. All right, I'm gonna call that good. I'm going to stop my recording.